Welcome. If you like the content that I produce, please click the subscribe button now. Alright, so to begin, let's discuss some of the more fundamental aspects of mathematics. One of the most important concepts in mathematics is the notion of a proof. In order to prove something that is mathematical, it must first be described in a relatively standard way that allows the audience to comprehend what precisely the mathematical statement is that is intended to be proved. Okay, fair enough. How can this be achieved? Well, one of the tools that is useful in this endeavor is the notion of quantifiers. One of the other tools that is particularly relevant is the notion of a set, although I'm going to skip over what exactly a set is here. I think the idea behind a set is intuitive enough for most people to grasp it without explicitly explaining it here. Alright, so what is a quantifier and how can this help us to understand mathematical statements and expressions? Okay. Let's start with something simple. Let's devise a set S of integers 2, 4, 6, 8. Now, if I wanted to make some mathematical statements about this set, I might say something like, all of these numbers are even, and I might say, there is at least one number greater than 7 in this set. In order to more precisely define these statements, the notion of a quantifier is introduced. As an aside, I'll briefly describe some of the notation that I'll be using here. I have noticed that mathematics textbooks tend to have large compendiums of notation towards the beginning of the text. However, the way that I have decided to structure this content makes that approach a bit less appealing. I decided instead to explain various bits of notation that I think may be important as I go. In this case, the element of symbol looks like a capital E, and this generally means an element of when the expression is converted to verbal English. The braces symbols often will denote the beginning of a description of a set and the end of a description of a set, with the opening braces denoting the beginning and the closing braces denoting the ending. The interior expression contained within the braces usually helps to better define the set, and this covers various different approaches, methods, and symbols. I won't cover them all here now. One that is particularly important, however, is the use of commas to separate logical notions or elements in an expression, and the use of the vertical bar symbol to denote the phrase such that, as in every element of a set such that a certain property, like being even, is true. Okay, so those are some of the phrases and notation that can help to clarify mathematical expressions, and then these expressions can be understood by the audience to have very precise meaning. Right, so what is all of this about quantifiers? The universal and existential quantifiers are typically understood as two specific symbols with associated phrases and meaning. The first one is the every or all of universal quantifier symbol, which is usually an upside-down capital A symbol. When used in an expression, like every x element of S such that x is an even integer, means that all of the elements in S are even integers. In this case, the use of the every or all of universal quantifier helps express that I am attempting to describe a property of every element in a given set of elements. The next quantifier of significance is the there exists or existential quantifier. The existential quantifier expresses that there is at least one element within a given set that has a particular property. For example, there exists at least one x element of S such that x is greater than 7. I have left a few crucial details out here, like what a variable is and why I used x here. I won't spend much time explaining that. However, a quick description is that single letters or even sometimes short phrases or words can be used to reference something else. And when attempting to form mathematically precise expressions and statements, it is helpful to allow a single letter, like x, to represent a particular element of a set, such as x element of S. The naming conventions, notations, and expressions surrounding variables can also take some time to work through, and so I will leave that out for another time as well. Okay, so there are two crucial quantifiers discussed so far. One helps convey properties of all elements in a set, the other helps convey the properties of a single element in a set. There are interesting properties, especially logical ones, that are relevant to quantifiers. The quantifiers can also be combined in much the way sentences can be formed by combining elements of communication to make more complex statements. For example, there exists an element x of set S such that for every element y of S, x is less than or equal to y. The mathematical expression for this could be written as shown. Note, the vertical bar is typically used within a set to mean such that, meanwhile expressions outside of a set might use either a comma or a colon to denote the phrase such that. I tend to prefer the colon when greater clarity is desired. There are other important aspects of mathematical expressions and quantifiers, as well as logic, that are significant when attempting to comprehend mathematics and proofs. I won't go over those aspects now, and I leave investigating those concepts to the audience to perform on their own. The topics surrounding logic and notation could cover things like showing that the negation of a quantifier in an expression can be represented in terms of its complementary quantifier. For example, if I were to say, not every x element of S is an odd integer, then I could represent that expression instead of, there exists x, an element of S, such that x is not an odd integer. As it turns out, these statements are logically equivalent. The notion of quantifiers and how they are influenced by logical operators helps to clarify this. As stated, I won't review the other logical operators and their influence on mathematical expressions in this video, but I will hint at them, and I will use other logical operators in future videos. I assume that the audience will have either learned more about those operators on their own, or are sufficiently competent to use context clues to accurately guess at the meaning of the operators in question. Thanks for watching. Goodbye. See you in the next video about limits.